Hello everyone, this is Nirmani Geek Sandesh YouTube channel. Today we are going to discuss about logic gates. Logic gates is very important lesson. Let's discuss about that. Before that, if you haven't subscribed to my channel yet, please subscribe and join with us. And make sure to click on the bell icon to receive the notifications regarding the new YouTube videos. Right, let's discuss about the logic gates. Today we are going to talk about six main logic gates. This is NOT gate, this is AND gate, this is OR gate, and the NAND gate, the NOR gate, and exclusive OR gate, XOR gate. So we are going to learn the symbol, how we are drawing it correctly, and what is the main logic behind that, truth table, Boolean algebra, and logic statement. Let's go one by one. If you have any questions regarding any of the things that I'm discussing with you, make sure to put a comment in the comment section. I will definitely answer to that. So first let's talk about NOT gate. NOT gate. NOT gate is also known as inverse gate. Let's see why is that. This is the symbol of the NOT gate. This is known as inverse symbol. NOT gate is having only one input and only one output. Every logic gate is having only one output. Yes, that is true, but this is the only logic gate which is having only one input. So let's name input A and this is output X. Input A, output X. So in order to prove how it's working with zeros and ones, we draw truth table. So here in this NOT gate, if it receives 0, it will output 1. If it receives 1, it will output 0. That means it's inversing the input to the opposite. So in the truth table, we can draw like this. Input A, output X. There are only two possibilities, 0 and 1. If input is A, output will be 1. If input is 0, output will be 1. If input is 1, output will be 0. Right. So we can say the NOT gate inverse the input. That's the main logic. NOT gate inverse the input. After that, you should know how to write the logic notation, or as we say, logic statement. Right. In here we can say output X equals not A. Then the Boolean algebra. Output X equals A inverse, or else you can draw it like this. You can write like this, A inverse. Both methods accurate and accepted. Depending on the exam, some syllabuses accept this method, some syllabuses accept both methods. That different. So please check what is accepted by your exam and please use. So every logic gate, we are going to talk about the logic gate symbol and what is the main logic, truth table, logic statement, and Boolean algebra. I hope you understand about the NOT gate properly. If you have any question, as I told you, please make sure to put a comment in the comment section. Right. Then let's go to discuss about other logic gates. The next logic gate is about the AND gate. AND gate. In the AND gate, this is the symbol. AND gate will have two or more inputs, I will name as A and B, and this is output X. So here, the main logic you have to understand. There are different ways that we can give the input for the this AND gate, but there is a very special input combination. When inputs are both ones, then only output will become 1. We can say when both inputs are 1, output is 1. Or else you can say when both inputs true, output become true, like that. So here the truth table we can draw like this. Here A, B and output X. Then I'm going to use some combinations. At the end of the discussion of these logic gates, I will teach you how we can get these input combinations. Right. Here I'll use 0, 0, 1, 1, 0, 1, 0, 1. And here the special case 1, 1, 1. That means you can remember it very easily. 1, 1, 1. All the other combinations zeros. So here what you need to understand is that in the AND gate, in order to get the true as the output or as 1 as the output, both inputs should be 1, all the other inputs 0. Using that fact, you can remember the main logic of AND gate. You have to remember these things. In logic gate lesson, actually very few things are there to remember. Other things that you have to practice and understand how to do that. The things that you need to remember are the symbols, main logic, truth table, how to write the logic statement, how to write Boolean algebra. So here the logic statement we can write like this. X equals A and B. Boolean algebra. X equals A dot B. This dot symbol representing the keyword AND. So we say X equals A and B. That's about the AND gate. The next logic gate that I'm going to discuss is the NAND gate. That means opposite of the AND gate. What do you think? If the AND gate providing 3 zeros, 1, then NAND gate will provide 3 ones and 0. Let's look at it now. There are actually 3 main basic logic gates. Those are NOT gate, AND gate and OR gate. Other logic gates are combinational logic gates. Those are actually arranged by using other logic gates. Now let's see the NAND gate. NAND gate, another name we are using, NOT AND gate. NAND gate symbol is like this. The AND gate symbol, we connect the inverse symbol. There will be 2 or more inputs. I will name them AB, output is X. This is exactly similar to this symbol. When you have an AND gate connected with a NOT gate, like this. AB inputs, output X. This is same as this. So in logic circuits, if they are asked to replace some logic gate combinations with simpler single logic gates, you can actually apply these things. Here, when you have an AND gate preceded by a NOT gate, you can draw NAND gate for that. These things are really nice to learn. So let's see the connection between AND gate and NOT gate. First, let's see the NAND gate logic. So NAND gate, this symbol is this. What is the main logic? when both inputs are ones, output is 0. That's the main logic behind this. So let's draw the truth table. Let's draw the truth table by using the AND gate truth table so that you can understand it much better. Here, truth table. We can draw like this, AB inputs. Let's draw AND gate, after that NAND gate. In a question, if they ask you to draw the truth table of NAND gate, then no need to write this column. Here I'm writing like this for your understanding. Here 0, 0, 1, 1, 0, 1, 0, 1. AND gate 1, 1, 1. For all the other combinations, output is 0. That is a fact. Then NAND gate means not AND gate. That means inverse of the AND gate. Therefore, zeros will become ones and 1 become 0. You can easily remember. If you can remember AND gate, through that you can easily get the NAND gate logic. Right. How to write the logic statement? Logic statement you can write like this: X equals A NAND B. There are some other similar ways that we are using for that. Then Boolean algebra. Boolean algebra: X equals A and B whole statement inverse. Or else you can put a bracket also. This is how we write logic statement and Boolean algebra for NAND gate. So please remember these facts using AND gate. Then it's very easy. Right. Now let's see the other basic logic gate. Now we discuss about two basic logic gates. They are NOT gate and AND gate. One combinational logic gate, that is NAND gate. Now let's see the OR gates, the final basic logic gate. OR gate symbol is this. It's a very special symbol, you see. 2 inputs. Inputs A, B, and this is output X. Here, what is the main logic of this? Actually, the OR gate, if both inputs are 0, output will become 0. If both inputs are zeros, then output is 0. Then how can we draw the truth table? Truth table we can draw like this. A, B, X 0, 0, 1, 1, 0, 1, 0, 1. So here, according to the main logic, 0, 0, 0, all the other combinations ones. So how can we write the logic statement? Logic statement we can write X equals A, O, B. Then Boolean algebra. Boolean algebra we can write like X equals A, O, B. Then actually the main opposite of this OR gate is NOR gate, N-O-R, NOR gate, that is known as not OR gate. And there is the XOR gate also, that is somewhat different from this, but there's a connection also. Here, let's discuss about the NOR gate now. Let's understand the NOR gate facts using OR gate facts. Somewhat harder. Right. The NOR gate is like this. You can draw it like this, and here NOR gate, that's known as not OR gate. NOR gate, also known as not OR gate. That is just like NAND gate. That is also known as not NAND gate. No? So it's like that. So we can draw like this. The OR to the OR gate, if you combine the inverse symbol, that's become the NOR gate. So there are two or more inputs. We can name A, B, and output is X. This is exactly similar to when you combine OR gate preceded by a NOT gate. This is same as this. Right. So what's the main logic behind this? Here, when both inputs are zeros, then output is 1. Let's see how we can get it. To table, you can draw like this, A, B, and here let's get O, and here let's get NO. Right, it's difficult to pronounce sometimes, right? So the 0, 0, 1, 1. Space is not enough. That's right. Smaller 0, 0, 1, 1, 0, 1, 0, 1. Then OR gate 0, 0, 0 for all the other combinations. Output is 1. And here NOR gate provide the opposite of the OR gate. So 0 become 1, and for all the other combinations it will become 0. So we can write the logic statement like this. X equals A NOR B. Then Boolean algebra. Boolean algebra we can write X equals A plus B whole thing inverse. Right. So this is another combinational logic gate, NOR gate. So using OR gate, you can remember the facts regarding the NOR gate. Now let's see about the last logic gate, that is XOR gate. XOR gate little special. Its symbol also having specialties. Actually, there are different ways that we use to draw this XOR gate. So in the XOR gate, there are two different ways. In one method, we are touching the outer line. The other method, we touching the symbol itself. In the XOR gate, it's known as exclusive OR gate. Exclusive OR gate. So here, the symbol is special. We can draw it. Mostly we are drawing it like this. Lines touching the outer outline only. These are the two inputs, and this is the output. Or else we draw it this way also. Lines are touching the inner line like this. Both methods correct according to the syllabus. You have to see which method your syllabus is following and please use that. Then the truth table. Truth table, you have to separately remember this truth table. That's very special. A, B, X 0 0 1 1 0 1 0 1. And here the output for 0 0 it will output 0, 1 1 also 0, for 0 1 and 1 0 it will output 1. So what you can understand using this, actually when inputs are similar the output is 0, right? Using that fact you can remember about this exclusive OR gate. When inputs are same, output is 0 like this. Then logic statement, we can write like this: x equals a XOR b. Boolean algebra, that is very special. There are different ways you can write. This is one special method. X equals a plus symbol and draw a circle to touch the lines of the plus symbol and 3. So this is about the XOR gate. So we have discussed about NOT gate, AND gate, OR gate, NOR gate, NAND gate and XOR gate. So how can you remember these facts easily? Every logic gate, as I told you, you have to remember these basic facts. Then you can draw the circuits easily. Then drawing a circuit for a given statement, or from when the statement given, drawing this diagram, vice versa you can do. And other next lessons also would be really easy for you if you understand the basics very well. So let's see how can you remember these facts easily. To do that, we can use a special way. You can use like this, okay? NOT gate, this is a short note that you should have after learning about all the 6 logic gates. NOT gate, for 0 it will be 1, for 1 it will be 0, and for AND gate 1 1 1. For 1 1 inputs, output will become 1. And OR gate, to that you can remember the NAND gate also. NAND gate 1 1, it is 0. Then OR gate 0 0 0, NOR gate 0 0 1, and exclusive OR gate 0 0 and 1 1 will output 0. Using this short note, you can understand the logic gates easily. Okay, now let's see in the truth tables how we can get the input combinations. In the NOT gate, like simple logic gates, we have discussed for 0 it will output 1 and for 1 it will output 0. Starting from the AND gate onwards, we need the input combinations. There is a connection in that. If there are 2 inputs, there will be 2 to the power 2, that means 4 input combinations. That means when there are 3, 4 inputs, that's multiplied. Let's see that now. In the AND gate like logic gates, we see there are 2 inputs and there are 4 combinations. 0 0 1 1 0 1 0 1. These are the input combinations that we got. So here, this is 2 to the power 0 equals to 1, 2 to the power 1 equals to 2. And here, actually, we number them 0, 1, 2, 3. The line number 0, no need to use any of these values, that's 0. So here 2 is here 0, we are not using. Here this value 1 also 0. It's like this. When you are using this particular value, we put 1. If you are not using, we put 0. So here we are not using any of the values. That's why 0. So 0 plus 0, 0. Line number is 0. And here we are not using number 2. Therefore this is 0. We are using this column's value. That's why this is 1. 0 plus 1, 1. Column number is 1. Here 1, 0. We are using this column number 2 plus. Here 0, 0. 2 plus 0, 2. Here we are using both values. 2 plus 1, 3. So 0, 1, 2, 3 same as the column numbers. Actually, we using these header values in order to get these column values. We write these values inside the truth table. That's why it's become 0, 0, 1, 1, 0, 1, 0, 1. So if you consider other combinations, if you have 3 inputs, there will be 2 to the power 3. That means 8 input combination. If there are 4 inputs, there will be 2 to the power 4, 16 input combinations. Remember that. That's how we get the input combination. So that's why when you have 3 inputs, 8, 4 inputs, 16 like that we'll get. So if you visualize it, when there are 8 inputs, you can remember it using the pattern. Let's try A, B, C. Here 4 zeros, 4 ones. The space is not enough. 2 zeros, 2 ones, 2 zeros, 2 ones, 0, 1, 0, 1, 0, 1, 0, 1. So use the pattern. Here 2 zeros, 2 ones, 0, 1, 0, 1, 4 zeros, 4 ones, 2 zeros, 2 ones, 2 zeros, 2 ones, 0, 1, 0, 1, 0, 1, 0, 1. You can remember the pattern and please understand the logic behind the input combinations. Then you can easily get this. So in some question papers, they are given these input combinations, and in some papers actually they are not giving these input combinations. If they are not giving the input combinations, you have to make sure you are correctly writing the input combinations so that you can get the output properly. Most of the students having a problem, like let's say they are given a description like this is A is this, B is this, like that, but they haven't given what is the order. Is that ABC, BCA, what is it? So whatever the combination that you get, you will get the correct output, but the output order will become little different. That's the only thing. There's no any problem regarding that. So today we have discussed about the 6 main logic gates, the logic gate symbols, truth tables, Boolean algebra, and logic statement, and the main logic behind that. Other than that, we have discussed what are the interactions between the logic gates, and after that we learn one of the special thing, how we can get the input combinations also. In upcoming videos, I plan to discuss some other important topics related to logic gates and logic circuits. Please put some comments in the comment section regarding the video, the content, whether you like it, and what are the other things that you would like to hear from my channel, like that. Okay, this is Nirman, Geeks and Rich YouTube channel, and please subscribe if you haven't subscribed us yet, and make sure to click on the bell icon to receive notifications regarding new videos like this. Have a nice day.